Welcome to Enterprise Java in 3.x video. Before I start, let me introduce about myself. My name is Sanjeev Tripathi. I have 20 years of experience in software development, design and architecture. Most of my experience is in developing, designing and architecting Java J2E applications. In most recent year, I also involved with the mobile application technologies and single page application technologies as well. Let's start. In this video, I will cover what is the Enterprise Java Bean, benefits of Enterprise Java Bean, types of Enterprise Java Bean, EJB lifecycle, and how to access Enterprise Java Bean from the client. At the end, I will provide demonstration of the different kind of Enterprise Java Beans. So what is Enterprise Java Bean? Enterprise Java Bean is J2E component which encapsulate business logic. So we are creating entire architecture, entire J2E architecture. We can use EJB for creating server-side component to encapsulate the business logic. Benefits of EJB. There are many benefits of using Enterprise Java Bean. First of all, it simplifies the development of large-scale enterprise applications. Developer only need to concentrate on writing business logic of the application. They should not worried about other boilerplate things like creating EJBs, removing EJBs, activating EJB, passivating EJBs. They don't have to manage life cycle of the EJBs. Security and transaction management is also handled by container, and container can also provide the pooling of the instances of the EJBs. So container provide a lot of benefit, a lot of features that our entire architecture take the benefit of it. There are two types of EJBs, Session Bean and MessageDriven Bean. Session Beans encapsulates the business logic that client can invoke directly. Message-driven beans are the JMS listeners. So you create your own message method in it, and when a message comes to the queue or the topic, own message method gets called. Client does not access message-driven bean directly. Session beans are of three types: stateless session bean, stateful session bean, and singleton session beans. Stateless session bean. To create a stateless session bean, we use stateless annotation. Stateless session bean does not maintain a conversational state with the client. So if you are calling stateless session bean from the client multiple times, these all the calls are independent of each other. There is no client state is maintained between the different calls. We use stateful annotation to create the bean as a stateful bean. Stateful session bean keeps client conversational state between clients. Stateful session bean instance is not shared between clients. So when client calls a stateful session bean, instance of the stateful session bean gets created, and then you're calling stateless session bean multiple times from the client. It maintains the conversational state. So these calls are dependent, and container does not share this instance with the other client. This instance is dedicated to that particular client and it can call multiple times. However, container can passivate. To improve the performance, it can passivate the client state to a database or hard disk. So this instance can be passivated. After some time, the client calls again, the container can activate this instance. So container does this for increasing the performance. If some reason it needs the instance for another client. Singleton Session Bean. We use a Singleton annotation to create a Singleton Session Bean. Singleton Session Bean is similar to the Stateless Session Bean. There is some differences there, like Singleton Session Bean can have only one instance in JVM or application. So there is one instance per JVM or per application. There are many clients can access that instance at the same time. However, in case of Stateless Session Bean, the instance is assigned to the client from the pool and only one thread can execute at a time. That instance is returned back to the pool, and once it's returned, then this instance can be used for another client. But at a time, only one client can execute a particular instance at a time. There is no two clients can execute same instance at the same time. There are a few more annotation interesting related to the session bean. These are local, remote, and local bean annotations. We use a remote annotation if we want to invoke stateless or stateful or singleton bean from the other machine or other JVM. So if we want to invoke remotely, then we use a remote annotation to the business interface. We use a local annotation to the business interface if we want to invoke the bean from the same application, from the same JVM. Then we use a local annotations. It improves the performance. We can also create a session bean without a business interface. In that case, we need to use a local bean annotation. So local bean annotation enables call to the EJB without a business interface. We use a message-driven annotation to create the message-driven bean. Message-driven bean have a own message method, and it is associated to a queue or topic. So message-driven bean have meaning in context of JMS message broker. These are basically a listener, message listener, and any instance of message-driven bean can process the message as they are all same. So container creates a pool of the message-driven bean instances, and when the message comes to the topic or queue, an instance get assigned and own message on that instance get called. Lifecycle of beans. So each enterprise Java bean have a different life cycle. We can also create a callback method using the different annotations like post construct, pre-destroy, pre-passivate, post-activate, init and remove. We can use these annotation to create a callback method. We can give any name and just use the annotations. These all annotations are not applicable to each and every enterprise Java bean. All callback annotations are applicable to the only stateful session bean. Lifecycle of stateless session bean. Stateless session bean have two states, does not exist and ready. Container creates a pool of stateless session bean instances. During creation, first it see if there is any dependency injection is there, then it injects the dependency injection. Then see if there is any post construct callback method is there, then it can call the post construct callback method. In a ready state, client can invoke the stateless session bean methods. When container want to remove the instance, at that time, if there is any pre-destroy method, callback method is written on the bean, then container calls that method before removing the bean. So the resources can be cleaned during this call. Life cycle of stateful session bean. The life cycle of stateful session bean is initiated by the client. First, client create the instance, then it see if there is any dependency injection that need to be injected and inject that. Then it see if there is any post construct callback method written on EJB, then it calls the post construct callback method. After that, it decide if there is any init method. If there are many init methods, it decide make a decision which init method need to be called. So it's called init method, and in that case, instance becomes ready. In a ready state, a client can invoke the EJB methods. During the time, if container see there is a need of passivating the instance, stateful session bean instance, in that case, it can passivate the instance to the hard drive or the in database. Before passivating it, if there is any pre-passivate callback method is there, it calls that, and when client invokes the method on a bean again, then it can activate again. So before activating it, it first called pre-activate method, and there we can bring the state back, and then the EJB method can be executed. Client can also remove the stateful session bean, like for example, in case of shopping cart, when payment is done, the order has been successfully placed. In that case, there is no need of shopping cart EJB. So client can invoke the remove method, and the shopping cart EJB, stateful EJB can be removed. Life cycle of Singleton Session Bean. Like a stateless session bean, a Singleton Session Bean has two states, does not exist and ready. The only difference is there is only one instance gets created in case of stateless, in case of Singleton Session Bean, and once the instance is ready, many clients can call the method on Singleton Bean at the same time. Like a stateless session bean, MessageDriven Bean also have a two state, does not exist and ready. Container creates a pool of the instance. If there is any post construct callback method is there during creation of the instance, is called that method, and whenever container want to destroy the instance, it can call the free destroy callback method if there are any exist. In case of ready state, the instance can take and execute own message method multiple times depending on the number of messages comes to the queue. Client access. There are two ways to access the EJB. One is GNDI lookup, and there is dependency injection using EJB annotation. So instead of creating GNDI in initial context and then doing the lookup and casting, in case of dependency injection, the container do the lookup and inject the EJB reference automatically. Each vendor implement the GNDI namespace differently, but if we are using Java global GNDI, then it's more portable because all the vendor have agreement on Java global namespace implementation. Enough with the theory. Now time for demonstration. I will use Eclipse Neon Point 2 and Wildfly version 10 from JBoss as an app server. Okay, let's create a new enterprise application project. Give a name. Click finish. Now let's create a new EJB project. Give a name. Add this project to the sample AAP ER project that we just created. Click finish. Now let's create a EJB. Give a package name. Give a class name. Let's say sample stateless bean, and state type is stateless, and create a business interface with the annotation remote. Click finish. So we have a bean here and we have interface. It have annotation stateless and interface have annotation remote. Now let's create a public method to this business interface. Which takes a string parameter and returns string parameter. Name. Let's save this. Go back to the bean. And implement this method right here. Okay, let's change it. So it returns greeting, hello, name. Okay, so our EJB is ready. We can come here and we can deploy it to the app server. You see, now this is added to the app server. Let's start the server now. It will take a few seconds. So server has been started and our project has been deployed. We can see the JNDI name for the EJB that we created. So this is a global JNDI name. We will use this for lookup. Now let's create a web project. Give a name. Click finish. Now let's add a servlet to it. Let's give a name sample servlet. Click finish. So we have a servlet which have a do get and do post method. We need a EJB client jar in a web project. So let's export this EJB client jar. And add to the web INF folder. Now we'll inject the EJB to the servlet. We'll use EJB annotation for this. That's the imports. So we have injected the EJB to the servlet. Let's save it. We will pass JNDI name to the EJB annotation. We will use mapped name annotation argument. And we will send the JNDI name as a value of map name. So we'll copy this global namespace JNDI name from the console. Copy here. So this will be the value of mapped name. Container will use this JNDI name for sample stateless bean lookup. Let's save it. Now let's go to the do get method and call our EJB here. Service dot say hello and pass the parameter David. Save it. Now run this servlet. This will deploy on Wildfly. and it will run. Okay, this is the result. So hello David is coming from the EJB. Say hello method. So our stateless EJB is working, and we are calling this from the servlet. Now we will create a stateful enterprise Java Bean and Singleton Enterprise Java Bean. Let's go back to our EJB project. Right click on package, new session bean, give a name, sample stateful bean. We need a state type stateful. We need a business interface to check remote. Click finish. So we have a stateful bean here. We have a remote business interface. This have a remote annotation. Let's create a public method, interface method. Public get count, and this returns integer. Let's save it. Go back to our stateful bean. Create an instance variable, private int count. Assign this to 0 and implement the interface method. Change return to count. So we return the count, and we will increment the count while returning. So our stateful bean is ready, which have a get count method. We will add now Singleton Enterprise Java Bean. Give a name. Okay, state type is Singleton, and we need a business interface. So click the remote. So here we have a Singleton Bean. This is a business interface. Which have annotation remote, that means it can be called from outside JVM. Let's add a public method which will return a string type, get data, save it. Let's go back to Bean and implement the method here. Okay, let's add a private instance variable of type string and assign value to say application data, and return this variable in a get data method. Save it. So our Singleton Bean is ready, which returns the cache data, that is application data, using the get data method. Now we will invoke these EJB from our sample servlet. Before we can do that, we need to export the client interface to our sample web project. Right click, export Click finish. Open the file, copy it, and now we will paste this to bed inf lib directory. Now we will deploy these new beans to the application server. So let's go to the server tab, right click, expand this application server and right click on sample EAP project and fully publish. So here we see the JNDI names for sample Singleton Bean remote, and this is JNDI name for Stateful Session Bean. So our both new Enterprise Java Bean has been deployed successfully. Now we will inject the Stateful and Singleton Bean to our sample servlet. So let's go back to servlet and create two more dependency injection. One for Stateful Bean, another for Singleton Bean. Change the remote reference to Stateful. And call this instance Stateful service. Similarly, change this dependency injection reference to Singleton. And change this reference name to Singleton service. Let's copy the JNDI name from console. So this is a global JNDI name for Stateful Bean. Similarly, let's copy JNDI name for Singleton Session Bean. So we injected Stateful and Singleton beans to our sample servlet. Now we will invoke getCount method from servlet's doGet method. So let's change this here. Stateful service dot get count, save it, go to server and publish this. Now we can run. We should get the result from Stateful Session Bean. Okay, count 0. So this is coming from the Stateful Session Bean. Running again. So its count is changing because we are increasing the number count by 1 every time. Now we will invoke the Singleton Session Beans get data method, which returns application data as a string. So let's change this to Singleton service and call the method get data result from Singleton. Let's save it and redeploy it, the web project. Is about to deploy. It deployed. Let's run it. Okay, so the result is coming from the Singleton Session Bean application data. That's what we were returning from Singleton Bean, so it's working. Now I will show you how to create a message-driven bean. So let's go to our EJB project. Right click on package. Select message-driven bean. Give a name. Sample MDB. We can select destination type as a queue or topic. Let's select queue and give the queue name, GNDI name of the queue. Let's say it is sample queue. Click finish. So our MDB has been created, which have one message method. Our GNDI name of the queue is a sample queue, and our destination type is a queue. So we need to register the queue with the GNDI name sample queue, and once registered and connection factory also registered, then whenever some producer is sending the message to this queue, this bean will work as a listener, and whenever the message comes, the own message method will be called. So whatever we are writing here in own message method will be executed once the message comes to the queue. This concludes the video tutorial on Enterprise Java Bean. Hope you liked it. Please leave the question or comment in a comment section. Thanks for watching Enterprise Java Bean video tutorial.